Hi, I'm Professor Rosen, and this is the first of many videos that I'll be posting online. So many of our lectures will be flipped. I plan on trying to flip a lot of them. That way there's more time for you to work, with me. And I'll be posting about that more in the syllabus video. So the first thing we need to do is I need to review and go over some topics from 1068 that may not have been fully covered or that you may have forgotten about. It has been a long summer. Specifically, what I need to go over is you probably remember encapsulation, but inheritance and polymorphism you may have forgotten a bit more, or maybe you don't have as good a grasp on those subjects. So in the next couple of videos I will be going over those. This first video will be building the base class that we're going to be working off of. So what is a class and what's an object? A class, right? That is that basically is a representation of something that exists in the world, or something that's abstract. It's a representation for something we want to build. A class is a collection, and what that means is that a class is a collection of attributes, things that describe the class, and the actions that members of this class can perform. Okay, so this is opposed to an object, which is an individual member of a class, right? So this is a animal class that we're building. So let's get away from that abstract stuff. This is an animal class that we're building. This is going to represent a bunch of animals. Each animal object is an individual animal. This represents the attributes that all animals have. That's what the class is. So let's go ahead and just come up with some basic attributes to model an animal, and we're going to make it really straightforward and not scary. Most we're going to do is just print line statements. So first things first, we want to make a bunch of attributes, and we keep them private, meaning that nobody else can touch them, right? So private string name, right? We'll give all animals a name, and we're going to give animals, let's go with another string color. Okay, just so simply we have another thing there to play around with. We're mainly going to mess with name. Color we'll touch on a bit. Okay? So these are the attributes that they have. Writing a class, we typically divide it into three parts. We got our attributes, then we're going to have our constructors, and then below the constructors, which I'll skip for later, we typically have our instance methods. Right? We have our instance variables here, and we have our instance methods over here. So public void. So here for the instance methods, you describe what animals can do. Let's go ahead and say that animals can eat, and I'll leave this blank right now, and that they can public void move, right? So animals can eat. Specifically, they eat things, so we'll go ahead and put that in, string thing. So remember, this creates a parameter for the method, which is a local variable that gets passed to it, thing. Okay, and to simulate it eating a thing, we're just going to do a print line statement, system.out.println this.name, right? And the this keyword is special. That means that this represents this particular animal. So if I create an animal named Andrew, which I will do, this represents Andrew. And then if I create another animal called Fred, this would refer to Fred. So it refers to this particular animal or that particular animal, right? It's not every animal, it's this one. So this animal's name plus eats blank plus thing, right? And let's say it just eats it generically, right? Because it's an animal, we don't really know how it moves. Oh, sorry, how it eats. And then we'll just do a similar thing for the move method. Oops. This dot name plus moves plus normally. Oh, we'll go, yeah. We'll go with normally here. Okay, so that's enough to actually start running this. So let's go ahead and, yeah, we don't have a constructor, but that's not going to matter. So let's go ahead and create we could make a main method in animal, but I'm going to keep it separate. So playpen is where we're going to play with all our animals. We're going to go ahead and create a public static void main method so that we can run it. We're going to create animal. A is equal to new animal. Right? We're going to create a new animal. So, right, what happens if you don't create a constructor? If you don't create a constructor, if you don't tell Java how to build your object, then it basically provides this for free for you. That's what Java provides for you for free, basically, with a couple caveats that we're going to get into. We're going to go ahead and just comment that out for later, right? That's what Java gives us for free, essentially, which is that we build it and we don't really do anything. But we can still make it, and we can tell it to move, and we can tell it to eat the greatest food of all, which is, of course, pizza. So let's go ahead and run this class. Okay. So null moves normally, and null eats pizza generically. Now, why are we getting null? Well, because the constructor, right, it does that. This blank constructor that it doesn't have, and that Java automatically provides for us, it doesn't do anything, right? It doesn't set anything up. It doesn't give us a value for the name. It doesn't have a value for the color, right? So as a result, when we go down here and we ask this.name and we're asking ourselves, well, what the heck is the name? Well, our program is just going to tell us that, well, it hasn't been set yet, so there's nothing in there, so the value is null, right? So if we've got an object over here, like name, like these strings, these values are going to get set to null if they don't get set up in the constructor. If we've got something over here, like private int size, like a primitive over here, then that will get set to 0, right? I'll go ahead and show you that. I'm going to immediately delete size, so you don't have to keep it around, right? Move. So we'll see a 0 get printed here, right? Because there needs to be a value stored in that memory location. And we'll be storing, so by default, if you don't define anything, Java's going to put essentially what comes down to a 0 value there. Okay. Okay. So let's go ahead and make a constructor then. So we're going to go ahead and make 2 constructors for this class, right? The first one we're going to make is just nothing. What happens if you don't set anything up? So we're going to go ahead and say this dot name is equal to, I'm not really going to use color much, is equal to Andrew. And notice that my IDE started changing colors of stuff, right? Name became red, and while color remained grayed out, that's just a hint to me that color never actually is getting used. We're never actually using it. So now, public animal, this.name, Andrew. If I run the class we were running, let's go ahead and run it. It will say Andrew moves normally, and Andrew eats pizza generically. So that's pretty good. So it's nice. I like pizza. But suppose we want to be able to provide a name. We want to specify a name. Well, then we go animal string name, and this will introduce a number of important things for us. First thing is that we can do multiple constructors for a particular class. We can tell Java that we want to build, that there's more than one way to build this class, which is awesome. Okay. And this is telling it that the particular way we want to build it is by providing a name instead. So I'll say this.name is equal to name. And now here we've got a very interesting thing here. Notice that that I use this.name is equal to name. Now this is actually standard Java format, like conventions over here to use this. So I've got this name over here, and notice if I click on this one, it highlights this name and the name over here. But if I do with this.name, it highlights, well, every instance of this.name and this one over here. Well, we've got, in Java, you have 3 types of variables, okay? So the first one is static variables, which exist up here, right? And a static variable is a variable that's stored among every single member of the class, right? It is some shared resource. So for animals, don't really have one there, other than basically maybe something along the lines of public static void. Sorry, public static Boolean has cell membranes, right? That's something that all animals have. And here that's would be a value that that all animals have, right? And I can go over here to animal and type animal dot, and it exists like this. Notice that belongs to the big thing here is that it belongs to the class and not to a particular object. So I can access it by going the class name dot, because it's static, right? I can't do that for name because that's something that belongs to an individual member. This belongs to basically every single member of the class. There's only one copy. That means if I have a million animals, I'll have a million different names, but I'm only going to have one has cell membranes. So it's useful if you've got something shared like pi that you don't want to, you've got some shared variable you don't really want to copy a whole bunch of times. They're essentially global variables. It's the closest thing to a global variable that Java has. Okay? Then you have instance variables, which, each object has a copy of an instance variable. Each animal has a name and each animal has a color. Okay? And then you have local variables, which are local to a method or a block of code, right? They exist only in that block of code. So this variable thing only exists between these curly braces. And it doesn't exist anywhere else, right? If I go and type thing here, it's going to ask me what the heck is that, right? And it's likewise, the local variable name only exists here. Now you can have local variables and instance variables named the same thing, but how do you tell them apart? Well, Java by default Java says, well, if you don't specify, local things are way more specific. So if you don't specify anything, then I'm just assuming you're talking about the local variable. If you want to get the instance variable, you use this dot if there's any confusion, right? But now let's go down to eat over here, to the eat method. Notice that there's only the instance variable there, so I'm allowed to just leave off this, and it knows, oh, well, there's no other name but the instance variable, so we'll let you use that. So you can leave off this to get the instance variable if there's no local variable named the same thing. If there is a local variable named the same thing, then you have to use this dot to get the instance variable. Now, why in the world do you want to do this? And why is this? Did I say this is the default way to do it in Java? Well, it's for reasons like this constructor. If you've got a bunch of things like, if you've got a bunch of inputs, a bunch of parameters, then it makes it very easy to line up and very easy to generate code, right? Let's go over here, code, generate, let's see, how do I generate, I think it's like control space, nope, auto, yeah, generate, alt insert, okay, generate a constructor, right, see, it makes it very easy for it to just match up those name to name, color to color. That way you know what variable goes to what variable, what local variable goes to what instance variable, without having to, without risk of getting lost. Okay, so let's go back to our playpen. Okay, so now we've got these methods. I'm still eating pizza. I'm still moving normally. I'm still eating pizza. And let's go ahead and now provide a name instead, and I'll go and use Alice. Alice moves normally. Alice eats pizza generically, so if I provide a name, it will set to the name. If I don't provide a name, so suppose I've got like 20 variables here, and I set it up here, and I really want to use as little code as possible. I'd rather like to reuse this constructor as much as possible. If I've got a constructor I want to piggyback off of, I can use this. So this is the other way you can use this, which is to call the keyword. So which is to call the constructor. So I can say this Andrew. I just provide the same number of parameters that are and the same types that are in the other constructor. So providing this Andrew, this will call the other constructor. So we'll pass Andrew to this constructor. So this constructor says, well, I'm being lazy. I'm just going to pass this parameter over to the other constructor and let it do all the other work. And so now if I do, I just leave it blank. And these, grayed out things, I don't actually put them there. That's just something that my IDE is going to be doing for me that to remind me what the parameter is. So there's going to be, that's one of two weird things my IDE does, which is puts in this hint for what the parameter was, right? I'm eating a thing, and what's the thing? It's pizza. The other weird thing that I'll do, that you'll see in a minute, let's see, is that my double equal is that my font acts very strange when I put in stuff like double equals, right? Two equal signs combines into one, or if I do a not equals, it will combine into that. So that's just some interesting things that I've done for myself. So anyway, we did animal A, new animal, and we ran it, and it worked. We got Andrew moves normally, Andrew eats pizza generically. Okay, so now we've got everything set up so that we've got our animal set up. Now we're going to start messing with our animals by creating different types of animals.